roll up your sleeves. Get down, get dirty, as these mechanical monsters drill, plow, and haul mountains and soil. From hundreds of feet below the Earth, to the deepest depths of the oceans, to neighboring planets within our solar system. Now, more Earthmovers on Modern Marvels. They make the ground tremble. They change the landscape. They move the Earth. They may seem like the world's biggest toys, but this is no game. These are multi-million-dollar workhorses that support billion-dollar industries, scooping out Earth's riches, relocating Earth's muck, crushing big rocks into little rocks, sometimes saving the environment, sometimes creating environmental havoc. The earth-moving industry is constantly pushing the boundaries of size and power. Today's earth movers dig deeper, tunnel farther, and transport more earth than their predecessors did just a decade ago. Yet ironically, the world's ultimate earth mover is as old as the Earth itself. It's the raw power of Mother Nature.
There's a tremendous amount of power that can be unleashed by storms or stream movement. It far exceeds our ability, what we can do as humans, to move soil in a rapid period of time.
On the Gulf Coast of Mississippi, what took men and machines decades to build was destroyed in a matter of hours by one of the most destructive hurricanes on record.
Hurricane Katrina made landfall in Mississippi on 29 August 2005, and it was a Category 4 hurricane, and the devastation was complete.
Winds clocked at 140 miles per hour, toppled trees, and leveled homes. In the aftermath of the deluge, the federal government declared 48 of Mississippi's 83 counties disaster areas. In ravaged neighborhoods like this one in Hancock County, only a few homes were left standing.
When Hurricane Katrina hit, there was 25 to 30 foot of water that came over this spot that we're standing right now that caused this entire devastation that's around us.
Earth movers that helped sculpt this neighborhood decades ago were given the task of removing the debris that now littered it. Overseeing the disaster relief effort is a fusion of government agencies, spearheaded by the Federal Emergency Management Agency, or FEMA.
FEMA has turned to the Corps of Engineers for debris removal, and they have a massive project that they need to work on. The debris removal is always one of the very first parts of recovery.
In support of FEMA, the Army Corps of Engineers initiated Task Force Hope. One of its main objectives, the removal of 24 million cubic feet of debris in 17 different counties across the state of Mississippi.
The end state of Task Force Hope is to assist the people of Mississippi to begin to rebuild their lives to a state it was before Hurricane Katrina hit. And we will do that with the help of earth-moving equipment.
Around the clock, earth movers continued to bulldoze, lift, and dump the ruins left over from Katrina's assault. Workers navigated their machines to the devastated neighborhoods through city streets. This limited the size of the vehicles they could use, adding months to the cleanup effort. It also created a potential life-threatening risk.
As the bucket loaders get the debris and swing over and deposit the debris in the dump trucks, they have to be ever vigilant of the power lines that are in there so that they don't get electrocuted.
Earth movers placed the vestiges of homes, some a century old, into dump trucks. From there, the remains would be shredded and placed into landfills.
The typical equipment used are your track hose, which we have behind us. They are normally used to pull the debris apart, to break it into pieces small enough to handle, and that bobcat that we have here behind us, which will take it and load it on the trucks.
For students in the Pass Christian, Mississippi School District, every ton of debris these earth movers hauled away was a step toward normalcy.
Get your pencil ready.
The middle school was completely damaged during the hurricane, and the high school was partially damaged. Once we got the debris moved, that allowed us room to bring in fill, bring the site up to a set elevation, which then allowed us to bring these units in and move forward to get the school open for the kids.
After a month, the earth movers of Task Force Hope were living up to the promise of the operation's name. But their arduous task had only begun. From hurricanes to earthquakes, to natural erosion, nature has been moving Earth for billions of years. But man's earth-moving efforts date back roughly 400,000 years, when our ancient ancestor, Homo erectus, started rolling big rocks around.
The cave dwellers needed to move soil around and rocks around because when you're living in a cave, you've got to have areas where you can store things. If you had animals and you wanted to fence them in, you're going to have to create a fencing system. Rocks were one of the first technologies we could do to create fences.
Humans were soon digging holes, removing dirt in woven baskets, and digging out mud for bricks. We're still digging holes, but we're better at it now. A lot better. This is no woven basket. It's a 320-ton Komatsu Haulpak 930E, one of the largest mining trucks in the world. Clearly, this isn't your typical pickup. A man can walk underneath this vehicle without even bending over. The 6 tires have a radius of over 12.5 feet and cost more than $30,000 each. If you think you're spending a lot at the pump, it takes 1,200 gallons of diesel to top off the tank of a 930E truck. And if you're going to get behind the wheel of this mechanical beast, you better not be afraid of heights. The truck is 23 feet tall.
It's like driving a big old house with a cab sitting on top.
Komatsu Mining Systems is one of a handful of manufacturers of these large off-road trucks. Its plant in Peoria, Illinois, began as the dream of an inventor named R.G. Letourneau.
He manufactured scrapers, made his own welders, made wire rope, and basically founded this. So from that, we grew from construction to off-highway trucks.
Letourneau kept his engineers on their toes.
He would go around the shop and some piece wouldn't work or wouldn't fit or whatever. He would either redesign it on the shop floor with chalk, or he'd have an envelope in his pocket and he'd draw it on the back of the envelope, and it'd drive the engineers nuts just trying to keep up with him, because those were the changes for the next machine.
The innovative design characteristics of Letourneau's first Haulpak trucks are now standard on all mining trucks in the industry.
He'd make the truck short so it would have a short turning circle, make it maneuverable. But the major thing he did was that the truck weighed less than it carried. And all the trucks prior to the off-highway trucks prior to that weighed a lot more than the payload that they carried. There's a lot of efficiencies gained with that.
Trucks evolved from the old dump wagons of the 19th century, designed to haul and dump their load of earth. The advent of the internal combustion engine compelled companies like Mack to improve on horse-drawn wagons. Standard-sized trucks that worked on giant projects like the Hoover Dam often weighed more than their payloads. But when the true gigantic off-road trucks emerged in the late 1940s, their much larger payload capacity made Letourneau's lighter design much more practical. After Letourneau retired, his company passed through many hands and is currently owned by Komatsu, which now builds a vehicle with 10 times the hauling capacity of his first Haulpak. Things have changed since the days of blueprints on the back of envelopes.
I supervise 6 other engineers, and we're responsible for the design of the hydraulic systems on the trucks, as well as the brake systems, brake application systems, and final drive design.
Komatsu's largest trucks are partly powered by diesel and partly by electricity generated by the vehicle itself. The diesel engine is connected to electrical generators. Energy that's produced when a truck descends a hill is stored in batteries on the vehicle. That stored energy is then used to propel the trucks when they ascend hills, sending power to the large wheels. The trucks have no transmission.
Yes, it is more elaborate than your typical Ford or Chevy pickup.
The Komatsu plant, where these earth-moving brutes are manufactured, looks like a boneyard for dinosaurs.
The assembly process for a 930 takes approximately 10 days from the time the frame is set in this building and the assembly process starts.
Steel that makes up the 930's body can be 1.5 inches thick. Its engine produces 2,700 horsepower. The truck reaches a top speed of about 45 miles an hour. The vehicle is 27 feet wide and 50 feet long. And the volume of its bed is roughly 200 cubic yards. Once the truck is tested, it has to be disassembled and transported to the job site.
Typically ships by rail, requiring 3 rail cars to ship the wheels, the truck itself, and its components, but that does not include the bed of the truck.
Once on site, workers use the trucks continuously. 3 shifts a day, 365 days a year, for the life of the vehicle. That could add up to some 15 years, or around 100,000 hours of driving. A truck the size of the 930E costs over $2 million, so mining outfits must drive them hard to show a profit.
The name of the game in producing efficiently is asset utilization. When a customer, such as a large mine, buys a fleet of equipment, they're making a substantial capital investment, and they have to get every ounce of production out of that investment that they can get.
These trucks are used in all kinds of mines, from coal to gold, but they're most commonly used in open-pit copper mines. Operating 8 or 10 giant haul packs is cheaper and more efficient than using 40 or 50 smaller vehicles.
Having large equipment is a real advantage because you have one operator moving that soil, whereas if you had a whole slew of people out there, you're paying wages on these people.
And in an industry with a poor environmental reputation, these trucks produce less emissions per ton than smaller trucks and take fewer trips. The trucks are sized to match the shovels that do the actual digging on site, with optimum truck size being 4 passes, or swings of the shovel per load. Big trucks like these have to be accommodated with special wide roads.
It costs a lot of money in a mine to build a road for the trucks. They're changing all the time because they're making the mine wider all the time.
And if you're driving a regular-sized vehicle near one of these behemoths, watch out, because up in the driver's seat of a 930, the blind spot is enormous.
There are numerous incidents of pickup trucks being run over in mines by these trucks, and I will tell you, in a 320-ton truck, you can run over a pickup truck and not know it.
Getting more out of Earthmovers means getting more out of the earth. For Komatsu and the other big truck manufacturers, that means designing bigger and bigger vehicles to get more ore out of the mine. For other Earthmovers, it might not be precious metals they're looking for, but tons of soggy muck. The Letourneau Company, founded by earth-moving pioneer R.G. Letourneau, built nearly 70% of all the heavy earth-moving machines used by the Allied forces in World War II. More Earthmovers will return on Modern Marvels. Earthmovers can transform the world right before our eyes. But some change a part of the world that most of us never see. When it comes to reshaping the underwater landscape, the earth-moving workhorse is the dredge. The chief function of the world's dredging force is to clear debris from the bottom of shipping channels, so that commercial vessels, heavily laden with goods, don't run aground. In South Carolina, 40 feet above the earth it's moving, the mechanical dredge Atlantic works to deepen Charleston Harbor. The Atlantic is a bucket dredge. This type of dredge is most effective at removing soft sediment. The Atlantic is one of the largest bucket dredges on the eastern seaboard. In one scoop, it's capable of shuttling 32 cubic yards, the equivalent volume of an average-sized bedroom. The job in Charleston is two-pronged. The Atlantic is scooping muck that is shoaled in or migrated from one part of the harbor into the channel. It's also digging the channel deeper than before in order to accommodate ships loaded to deeper depths.
So we're actually doing about 4 feet of maintenance and another 5 or 6 feet of additional depth to increase the depth of the channel.
The Atlantic and most dredges today are sophisticated multi-million-dollar precision instruments using the latest global positioning systems and onboard computers. But it wasn't always like this. One of the earliest cultures to practice the science of dredging was that of the Phoenicians around the 13th century BC.
Early on, they were the leaders, you might say, in the maritime business, and they were progressive in terms of their military activities. They had to have a way to get the craft into the shoreline areas to load their soldiers so they could move them to some other area.
The Phoenician dredge consisted of a floating platform fitted with a tripod. On top of the tripod was a long pole equipped with a basket at one end. Workers would lower the basket to scoop up loose sediment and bring it to the surface. As ancient cultures began to depend more and more on shipping for trade instead of war, sophisticated dredging machines emerged. By the 14th century, innovators introduced mechanical dredgers in Europe. Later, steel and the internal combustion engine enabled these earth movers to achieve gargantuan dimensions and far greater efficiency. The Atlantic can rapidly fill up a scow that's able to haul 5,000 cubic yards of muck, or 157 bucketfuls.
If you're digging in mud with a large bucket, big mud bucket, you could load this scow probably in 2 or 3 hours.
Scooping up soft mud is one thing. Digging up and lifting heavy rock is another. For this challenge, get behind the controls of this monster. A backhoe dredge. The steel teeth of a backhoe dredge bucket can rip through solid rock with up to 370,000 pounds of force. The New York is the largest backhoe dredge in the world. In one load, it can bring up a staggering 26 tons of rock. But raw power isn't all this giant has going for it. It's got a brain to go with its brawn.
The computer's telling me how much material I still got to pick up. You know, it tells me where to dig, my digging lines, the actual depth of all the material that I need to pick up.
While mechanical dredges like the New York scoop, hydraulic dredges suck, and we mean that in a good way. Hydraulic dredges operate like super-powered vacuum cleaners, utilizing powerful pumps to suction material to the surface. The pumps connect to long pipes that extend down to the floor of the channel. The end of the pipe can be fitted with a variety of different heads, depending on the job at hand. The most common type of hydraulic dredge used in the United States is known as a cutter suction dredge. It uses a bladed head to fracture rock or loosen hardened ground. The bladed head revolves around an opening or mouth at the end of the pipe. As the blade penetrates the seabed, the fractured material is sucked through the mouth and emptied in a disposal or holding area on the surface. The hydraulic dredge Florida is one of the largest cutter suction dredges in the United States.
It's got a 3,000 horsepower cutter head. The pumping power is about 12,000 horsepower between the two pumps that we have.
Another type of hydraulic behemoth is the hopper dredge. It's a self-powered vessel that can store huge amounts of material in a holding tank, or hopper. It's often used to remove sandbars far off the coast. For quick removal of sediment in shallow waters, such as rivers, engineers rely on hydraulic dustpan dredges. You'll find these along the muddy Mississippi. Dredges may have become more and more specialized and complex, but their basic function remains simple. Still, they may become even more specialized in the coming years if the demand for overseas commerce continues to grow. As dredges reshape the ground beneath the surface of the water, other earth-moving wonders transform the ground beneath the surface of the earth. According to the American Association of Port Authorities, about 400 million cubic yards of material are dredged each year from American waters. That's enough to build a 4-lane highway 20 feet deep, stretching from New York City to Los Angeles. More Earthmovers will return on Modern Marvels. Just outside Cleveland, Ohio, several hundred feet below the surface of the ground, a giant drill known as a tunnel boring machine cuts its way through ancient rock. It's been tunneling down here for over a year and has carved a lateral shaft stretching 2.5 miles so far.
This whole project is being built as a storage tunnel to store stormwater and sewage runoff. What happens is that during the first surge of a rainfall, the sewers overflow into this storage tunnel, and then at a later time it's pumped out of this tunnel into the treatment plants.
2 shifts of 10 crewmen operate this mammoth machine 24 hours a day, 7 days a week. For these workers, getting to the job site takes several unique modes of transportation.
This particular project, we're going down underground now about 300 feet. We're in something called a man cage. We're suspended from the work crane over here, and right now, beneath your feet, 300 feet straight down.
The crane lowers workers through a vertical shaft to the tunnel floor. Next, they take a train traversing the 2.5-mile cavity that their boring machine has already excavated. After 10 minutes, they reach the back end of this giant mechanical slug, burrowing its way through the earth. The tunnel boring machine was built by the Robbins Company at their manufacturing plant in Austintown, Ohio, and was lowered into the tunnel by a crane, one piece at a time.
The tunnel boring machine was built in this first 200-foot section of tunnel. Hence, it had to be a little bit larger than what the tunnel boring machine wound up excavating.
The tunnel borer is equipped with 2 gripper arms on each side that stabilize the machine against the tunnel wall. As the cutting head grinds away, the grippers slowly push the machine forward. Buckets located inside the cutting head scoop up the fractured rock and dump it onto a conveyor belt. It's then whisked away the length of the tunnel and up a shaft, where it's finally dumped on the surface. This sewage tunnel is still a work in progress. A half mile still needs to be mined. When the tunnel is fully excavated, the boring machine, or TBM, will be disassembled and removed the same way it was brought in. The rule that the shortest distance between 2 points is a straight line is one that has always propelled the tunneling industry. Instead of building a road around a mountain, you go through it. Archaeological studies reveal that our prehistoric ancestors were adept at designing crude tools from animal bones for a multitude of uses, including digging.
They're nice and light, they're pointed, they're a wonderful scraping instrument.
But you can only dig so far with the bone of an animal. By the 19th century, shovels, picks, drills, and explosives brought tunneling some sophistication. Although none of these tools provided the kind of precision that came later with tunnel boring machines.
One of the main advantages is that you get a cut diameter fixed all the way through. Your concrete cost, therefore, is almost a known. Where if you drill and blast, you have a lot of overbreak, your cost of your concrete goes up considerably.
That can amount to total savings on the job in the vicinity of 20 to 25% over drill and blast methods. Tunnel boring machines have come in especially handy for creating tunnels in urban environments, where the noise and traffic tie-ups caused by explosions can be unacceptable. And they're much better for building small bore tunnels, which are too small for workers to gain access. Connect, a German-based manufacturer of tunnel boring machines, produces models in all sizes. Its largest sports a cutter head with a diameter spanning 47 feet.
The factory does the complete fabrication, the complete machining, the assembly. It's assembled in the shop. It's fully tested, and then it's broken down into shipping, and then it's shipped to the particular job site.
Each machine Connect builds is custom made for a contractor working a specific job. When the job is finished, the contractor might disassemble and store the tunnel borer, sell it, or reassemble it for another project. These sophisticated drilling machines might appear to be the pinnacle in tunneling technology. But Connect, Robbins, and other TBM manufacturers have plans for even better machines.
I think the future of tunnel boring machines in particular is in automation. That one day you'll see a tunnel boring machine, large diameter, excavating below a city with nobody actually physically in the tunnel. The excavation will be occurring remote control from an office above the tunnel. All the lining will be done automatically. All the equipment brought into the machine will be done automatically, and everything can be controlled from the surface.
When tunnel borers push through the earth and move it to the surface, it's a great achievement. When a plow turns the earth upside down, it can sometimes trigger a disaster. Some estimates place the amount of earth moved by humans each year at 45 billion tons. More Earthmovers will return on Modern Marvels. Giant trucks and dredges and tunnel borers move massive amounts of earth every day. Far more than an average farmer could hope to move in an entire year. Farmers move just a little bit of earth a few inches with a humble and unassuming plow. Yet this simple revolutionary mechanism helped contribute to a series of catastrophes in the 1930s, from which some farmers are still recovering. The Dust Bowl. 97 million acres of lush farmlands turned into a desert. The wind blew away the earth and the topsoil and forced thousands from the prairie they called home. Some escaped just ahead of so-called black rollers that blotted out the sun.
You'd run for cover, and after a while you learn not to worry about the chickens and the cows, but to run for cover yourself. I interviewed people that said they would put in clotheslines or ropes between the barn and the house, or between the outhouse and the house, because you couldn't find yourself around. It was like being in a black blizzard.
Throughout the history of agriculture, farmers have relied on various incarnations of the plow to break the land and turn the soil.
In 1794, the first iron plow that was developed was by Thomas Jefferson. Approximately 25 years later, the first steel plow came out, and then it had interchangeable parts. With the new steel plow, we could go down deeper and move a tremendous amount of soil.
By the mid-19th century, steel plows were revolutionizing agricultural production. But in the decades to come, farmers learned that these efficient tools had a disturbing downside.
A steel plow that could break that really tough prairie sod. And of course, once you broke it, it didn't heal. It was scarred forever, and the wind could get to it, and the elements could get to it.
Early in the 20th century, another technological breakthrough helped set the stage for the Dust Bowl.
About 1915, tractors just started coming on to the horizon. And agriculture started kicking into high gear. Tractors started really becoming on the forefront. We're farming 40 acres now versus 3 acres when we were with horses.
Yet another factor that led to the Dust Bowl was the enormous demand for wheat during World War I. Before the widespread use of motorized plows, just as the virgin prairie of southwestern Kansas was settled, farmers plowed under the grass and sowed the land with wheat. The earth was turned upside down by the farmer and his plow, multiplied by thousands of farmers with thousands of plows on millions of acres of once pristine prairie.
They called themselves sod busters, and they bragged about breaking the soil the way you would break a horse or break an animal, and that's what they did. They broke it.
By stripping the land of its natural vegetation, the sod busters had destroyed the delicate ecological balance of the plains, leaving nothing to hold the soil if the rain stopped and the wind blew. But throughout the 1920s, the weather was good. The demand and price of wheat remained high, and farmers were prosperous. Then, in October 1929, the stock market crashed, and farmers braced to reap what Wall Street had sown. The bottom fell out, and wheat went from $1 a bushel to 25 cents. It now cost more to grow wheat than to sell it. So farmers stopped growing, and fields lay fallow. Season after season, the topsoil was plowed deep into the subsoil. When rains dwindled, the topsoil dried out and eventually turned to dust. Fierce winds followed, blowing across the dry fields and stirring up great storms of dust.
Anyone who ever lived through it can tell you about it. It's a really frightening thing of having darkness at midday. They would wet bandanas or wet cloths or towels and put them over their face like this to screen out the dust so you weren't breathing that stuff in. People died of what they called the Dust Bowl pneumonia, breathing in that dust.
The drought continued for months. The months turned into years. Finally, families began leaving, abandoning their farms to seek hope elsewhere. But most stayed and suffered because they had nowhere to run.
Dust would blow in through the keyhole, so you wanted to get those wet towels and rags down to dust-proof your house. And of course, it was never possible. It would get in the chimney, it would get in through somewhere or other. And so whenever you came into your house, the damn stuff was all over. You'd rub a table and your hand would be dirty.
Some counties in southwestern Kansas lost nearly half their population. Abandoned, uncultivated fields only fed the dusty winds. Earth that took thousands of years for nature to craft blew away in minutes.
To have dust everywhere, know that you could never win that fight, that there was going to be dust all through your body, all through your clothing, through your food, that you couldn't escape it. It must have been a nightmare.
By 1934, over 650,000 tons of topsoil had blown away. After 10 years of unrelenting drought, dust and depression, it ended. The rains returned, making the soil less likely to blow. Grasses grew back in the dormant fields. Another world war soon raised the demand and the price for wheat. Prosperity had returned to the Great Plains, but farmers were determined to figure out why the Dust Bowl had occurred and what they could do to keep it from happening again. Beginning in the 1940s, the U.S. Department of Agriculture's Wind Erosion Research Unit, located in Manhattan, Kansas, has been doing just that.
I think our unit exists because of the Dust Bowl. The Dust Bowl was instrumental in creating the Soil Conservation Service. It was dust settling in Washington from the Great Plains.
The unit studied the causes of drought and the mechanics of dust storms.
So our mission is to understand the processes of wind erosion, develop predictive tools and control practices, and then transfer this technology to the people who need and use it.
The Wind Erosion Unit advised farmers on soil conservation techniques, from how to prepare the earth to how to till their fields.
We learned that we couldn't rely on just one system to take care of all of our crop production. We had to rotate crops. We knew that we had to go in certain areas that were prone to high erosion rates to go in and cover these areas with something that would prevent erosion.
As the government did its part to prevent another Dust Bowl, so did the farmers. They terraced their fields in order to conserve water. They developed irrigation systems to stave off drought. They planted trees as barriers against the wind. And they didn't use their tractors as intensely as before. The 1950s saw the return of drought. The skies again filled with dust. But this time, the farmers were better prepared. New farming techniques helped them weather the crisis and those that followed.
We've had numerous droughts afterwards. We just had a pretty bad one here in 1988. But the farmers have gotten better. The technology is better. So the farmers can go out there and farm the ground without causing an erosion problem.
The plow and the farmers who used it weren't the only factors that contributed to the Dust Bowl of the 1930s. Today we have a better understanding of the natural and economic cycles that also played a role. Farmers no longer bust the sod. They work it, they nurture it, and they support it, just as it helps support them. And when they do plow the land, they do so with the knowledge and experience learned from those dusty, windswept, and desolate days. According to recent statistics from the United States Department of Agriculture, approximately 800 million tons of non-federal cropland soil is destroyed by wind each year. More Earthmovers will return on Modern Marvels. Humans are moving dirt all over the planet at an unprecedented rate. Technology now allows us literally to alter the face of the Earth.
In the last century, we're seeing a huge change in our ability to move soil around. A farmer 100 years ago would take a whole day to do 3 acres. Now we can do an acre in 3 minutes.
Our prodigious earth-moving efforts are destroying Earth faster than it can be replaced. Nature crafts soil every day, created by seismic and environmental factors such as wind, gravity, rain, and decay. And it's destroyed by the same factors. Rivers wash soil into the oceans, and wind blows dust into the atmosphere. In fact, we may actually run out of Earth. As humans put greater burdens on the soil to support our ever-increasing population, we may have no place else to turn but up, to the 4th planet from the sun.
This is Mars, but it could very well be a lot of places on Earth. If you were standing out on this desert the way I appear to be right now, it would not be very healthy. The atmosphere is extremely thin, 100 times thinner than the atmosphere here on Earth. So it would be an instantly lethal environment.
The Martian air isn't only lethally thin, it's also extremely cold. The mean temperature is minus 81 degrees Fahrenheit. But Earthmovers, or in this case Mars movers, may someday be able to thicken and warm the Martian atmosphere enough to make it habitable. Trapped in the Martian soil may be compounds that can be turned into greenhouse gases. If these warm gases were created and released, they would melt the planet's polar ice caps and transform the Martian atmosphere into one resembling our own.
On Earth, the industrial processes that make these greenhouse gases are quite sophisticated. On Mars, we're going to have to literally start with dirt and start with Mars air and figure out some process to do that. What we would imagine is sending small units, small factories to Mars that would scoop up some dirt, suck in Mars air, undergo some chemical transformation, and release these greenhouse gases. And they just go around like ants around the Martian surface. And you might imagine thousands of these, all autonomously moving around Mars, processing the material, making these greenhouse gases. And we've done calculations that suggest if we could produce these greenhouse gases at a concentration of only a part per million in the Martian atmosphere, it would warm up the planet enough to start the process of melting the polar caps and releasing the CO2 in the water.
What would follow is an extraordinary process known as terraforming or ecosynthesis.
If we imagine Mars now becoming slightly warmer, now it's starting to look like the coldest places on Earth. As it warms up a little more, it might become like the top of a mountain. Sparse, tundra-like life, and just small bushes, small plants. And as it warms more, you can imagine coming down the mountain. And eventually, a key point in the history of Mars will be when it gets warm enough that the first trees can grow.
So how long would it take for this epic transformation to unfold? You'd be surprised.
We're We're not talking about something that's going to take millions of years or that has to wait for Star Trek inventions to happen. We're talking about something that could result in a biologically rich world in 100 years.
Maybe someday a Martian farmer will glance up over his shoulder at the big blue planet and be thankful that we learned so much about Earth moving back when we lived only on the Earth. That's assuming Earth isn't blown apart by a collision with an asteroid. But scientists are already speculating about ways to prevent such a calamity. Using a new breed of Earth movers, powerful enough to deflect any heavenly body racing our way.
We think there's anywhere from 1,000 to 2,000 objects about a mile in diameter or larger that are within the Earth's neighborhood.
But it's a big neighborhood. Scientists define near-Earth objects as those that get within roughly 30 million miles of Earth's orbit. Nevertheless, any body a mile across striking the Earth would be cataclysmic.
We know of one concrete example of a terribly destructive impact 65 million years ago. An asteroid or comet hit in the Yucatan and killed most species on Earth, including, most famously, the dinosaurs.
But don't worry. The number of large near-Earth objects is small, and scientists expect to hit only every 100 to 200,000 years.
So the object is to try and find the vast majority of these objects and keep an eye on them.
If we do spy one headed in our direction, Earth movers will likely be ready to save the day. Scientists theorize that the most effective of these might be the most powerful Earth mover ever created, a hydrogen bomb.
The most direct and probably the most efficient way of doing it would be to set off a nuclear weapon, not to blow it up, but simply to set it off near the surface of the asteroid so the neutron flux from this neutron bomb would ablate the front side of the asteroid and form a rocket-like thrusting of the material off the surface. And if we can give the asteroid just a tiny thrust, maybe a centimeter per second or so, over the 10 or 20 years that it would take for this asteroid to impact Earth, we would have moved it enough so that it would miss Earth.
Other alternatives include sending a spacecraft to hover over the asteroid, where the thrust from its engine would create a gravity tractor that would pull the asteroid away. Or the spacecraft could attach itself to the asteroid to push it away. In February 2001, NASA took a baby step toward realizing such a scenario.
NASA had a very successful asteroid mission to one of the largest near-Earth asteroids, Eros, in which the spacecraft orbited around the asteroid for a year and then landed and actually carried out measurements on the surface. So we certainly, with a scientific spacecraft, can do that, at least if we get to pick the asteroid. It's a little harder to do if it's the asteroid that picks us.
Manipulating the orbit of a near-Earth object is one of the challenges scientists feel confident they can overcome before any object comes plummeting close to Earth. In fact, we may launch Earth movers to mine asteroids and comets for minerals and fuels as we begin to colonize the solar system.
The things that we really need in space, first of all, water. It's iron nickel for steel, carbon. These things are present now in comets and asteroids.
All sorts of new Earth movers are on the drawing board, both for our own planet and for those yet to be explored. What began centuries ago as a simple effort to keep us sheltered and fed has turned into an engineering legacy that's a hallmark of the modern age. Humans are the ultimate Earth movers, designing bigger trucks and scoops and drills, moving Earth and moving beyond Earth into a frontier limited only